In order to solve the Dirichlet integral in record time, we need to invoke an integral formula from the Russian mathematician Nikolai Lobachevsky. Now that is a badass name for a mathematician, and I think it's pretty suitable because this integral formula is pretty overpowered when it comes to dealing with structures of the integral from 0 to infinity of sine x by x times some function f of x, which satisfies certain criteria. And that criteria is that f of x should be an even function of x, meaning f of x equals f of negative x. Next up, f of x should be pi periodic, meaning f of x plus k times pi equals f of x. So in that case, the integral sorts out to that from 0 to pi by 2 of f of x dx. And in our case, because we're integrating an even function of x, and we can verify this by replacing x by negative x, and the sine function is an odd function, so it spits out a negative sign outside, and these two negatives give you a positive, so yeah, we're integrating an even function over the symmetric interval. That means we can write it as twice the integral from 0 to infinity of sine x by x dx. And now, what exactly is our function f of x in this case? That's pretty easy. In the case of the classic Dirichlet integral, your function f of x is the constant function 1. And because 1 is a constant, it is automatically an even function as well as pi periodic. Oh, and if you're interested in a proof for Lobachevsky's integral formula, link in the description below for my previous video on proving both cases of the integral formula. Anyway, so because you have the required structure, you can write I as twice the integral from 0 to pi by 2 of our function f of x, which in this case is 1. So this sorts out to twice of pi by 2, which is, of course, pi. And there you have it. That's the Dirichlet integral in record time.